Hey, welcome class to lesson 1.3.2. This deals with radian measure in the unit circle and coterminal angles. Hopefully you watched the first video that talks about how special right triangles are in the unit circle, and then how the radian measure of an angle correlates to the cosine being the x coordinate for a point on the circle, and the sine of the angle being the y coordinate. On to the next slide. So this half of the lesson is then about coterminal angles. When you've been studying angles in the unit circle, most of your work has dealt with angles of a positive measure. The angle that I just drew is a positive pi over 3 radians. If I go to 7 pi over 6, this angle that I just drew is a positive 7 pi over 6. Because in both instances, we were going a positive direction, which happens to be in the counterclockwise motion. So, counterclockwise is a positive angle measure. Therefore, negative rephrase that, clockwise is a negative angle measure. So now we want to find in parts A, B, C, and D a positive coterminal angle. Coterminal just means that the angles end up in the same position on the unit circle. So think of it like this in part A. If I go a negative 2 pi over 3, which means I'm going to go 2 pi over 3 radians in a negative direction, what is the equivalent of going in a positive direction? So let's count out 2 pi over 3 in a negative direction. 1 pi over 3, 2 pi over 3. I'm at the same place on the unit circle as what positive angle measure? Well, that's 4 pi over 3. So therefore, a negative 2 pi over 3 is coterminal with a positive 4 pi over 3. Part B, 5 pi over 4. 5 pi over 4, let me erase the green stuff. 5 pi over 4 is, negative 5 pi over 4 is coterminal with what positive angle? So 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, there's 5 pi over 4. A negative 5 pi over 4 is coterminal with 3 pi over 4. Now, I'd like you to pause this and find positive coterminal angles for C and D. Please pause it now. Thank you for returning. In part C, if you go a negative 11 pi over 6, that would be coterminal with a positive pi over 6. And in part D, if you go a negative 3 pi over 2, that's going to be coterminal with pi over 2. On to the next slide. Coterminal angles don't just apply to one being negative and the other being positive. It applies to any two angles that end up at the same position on the unit circle. So let's take a look at what if we go more than one revolution around a circle? What if I want to go 10 pi over 3 units around the circle? Well, if I was to count out 10 pi over 3, and you don't have to do this because I'm going to erase it, that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pi over 3 takes me to 4 pi over 3. So 10 pi over 3 is coterminal but there's a faster and a better way to do this. And because we're talking about more than one revolution in a circle, let's manually remove revolutions from a circle. Now we know that one revolution is equal to 2 pi. So how many 2 pi's can I remove from 10 pi over 3? So if I revisit part A, pi over 3. I can remove a 2 pi over 3. Now in terms of thirds, I can subtract a 6 pi over 3. That leaves me with, my answer, 4 pi over 3, because I removed one revolution. Part B, 17, pi over 4. So I'm going to take 17 pi over 4, I'm going to subtract from it 2 pi, which is 8 pi over 4. And that leaves me with 9 pi over 4. Well, that's still more than one revolution. So I'm going to take 9 pi over 4. I'm going to subtract from it another 8 pi over 4. That leaves me with pi over 4. So 17 pi over 4 is coterminal pi over 4. Now I'd like you to pause this and try parts C and D. Okay, welcome back. In part C, you're going to negative 25 pi over 6. So a negative 25 pi over 6, without the direction of a negative, I'm going to be able to subtract 1 revolution, 2 revolutions, and that leaves me with pi over 6. So I've taken a positive 25 pi over 6, subtracted 2 revolutions, and that leaves me with pi over 6. But I still need to keep that negative direction, so that's a negative pi over 6, which then would be coterminal with 11 pi over 6, because it has to fall between 0 and 2 pi. In part D, we got 75 pi over 2. That is actually 18 revolutions. So 18 times 4 pi over 2 gives me 72 pi over 2. Subtract that from 75 pi over 2, and the location between 0 and 2 pi is 3 pi over 2, meaning 75 pi over 2 is coterminal with 3 pi over 2. On to the next slide. Sketch the location of the following angles. How many degrees? So we want you to make a sketch and then convert from radians into degrees. 11 pi over 6. When you're asked to make the sketch, and you'll be asked to do this in the homework, draw your coordinate plane, draw your unit circle. 7 pi over 6 is right in this area. So draw a line from the center to the point on the circle. Mark your angle and label it 7 pi over 6. Now I would like you to do the same for negative pi over 2 and 11 pi over 4. Draw it and then convert it to degrees. I almost forgot. The number of degrees 7 pi over 6 is? Well, that's 180 plus 30 more gives us 210 degrees. Pause this now and do a negative pi over 2 and 11 pi over 4. Okay, welcome back. A negative pi over 2, you're going to start on your x-axis, go in a negative direction, which is clockwise, pi over 2 units. That would be the same as a negative 90 degrees. For 11 pi over 4, you have to first subtract out 1 revolution, 8 pi over 4. That leaves you with 3 pi over 4. There's my angle measure of 3 pi over 4, which is equivalent to 135 degrees. Hopefully you enjoyed this video. Please tune in tomorrow when we start chapter 2.